Hey everyone, this is a quick proof on why 0 factorial is equal to 1. So we start with letting n be a whole number when n factorial is defined as the product of all whole numbers less than n and including itself. So if we were to write this out in a fully expanded form, it looks like this. We'll say n factorial is equal to n times taking that value of n, subtracting 1 times n minus 2, keeping with that, going all the way down till we get to a 3 times 2 times 1. Alright, we could also put this in, let's say, a more partially expanded form, and it looks as such. So we have n factorial equals n times n minus 1, taking the factorial of that quantity. Okay, if we looked at an example, let's say 5 factorial, then based on what we wrote above, it would look like as such. 5 times that number 5 minus 1 times that value of 5 minus 2. Alright, and we just would keep going until we get down, in this case, 2 times 2 times 1. So what it is 5 times 4 times 3 times 2 times 1. Alright, and then 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. So that's how we get 5 factorial. So we're going to prove that 0 factorial is equal to 1. So we start off with what we know, right? Our assumptions from this point. So we know that, and are assuming that 1 factorial is equal to 1 based on this process like in the example above. So if that's the case, then we'll use that partially expanded form again. So n factorial is equal to n times n minus 1 factorial. And now I'll just substitute in, let's say, 1. Let's substitute in 1 factorial. So if we did substitute in 1 factorial, I'll plug in the 1 for n, a 1 for this n. So we get 1 times the quantity of 1 minus 1 factorial. In our next step, we have 1 on the right side times what would be 0 factorial. So we're saying 1 factorial on the left is equal to 1 times 0 factorial. So 1 times 0 factorial must equal 1. So therefore, 0 factorial must be 1, right, in order for us to get a 1 on this entire side here. Right, so it must be 1. If not, we would get 1 not equaling to 1, which is a contradiction. So therefore, this is how we know that 0 factorial must be 1. So mathematicians defined it as such so that things will work out for us when using factorials.